Trigonometric derivatives, chain rule, Lagrange's notation. So, this first example, or this first formula, if you have watched my previous videos, you would know as just being a function within a function. That's when you use the chain rule, when you have functions within functions. And the derivative of this is when you derive the outside function, leave the inside function the same, and then multiply it by the derivative of the inside function. So, this here, same process, it's just it has three functions. This function, inside this function, inside this function. And same thing as before with this, except you just add another one on. So, you derive the outside function, and leave all the functions on the inside the same. Derive the second function, leave all the functions that are inside the same. And then derive the third function, and because there's no more functions inside to leave the same, we'll derive. That's when you stop. So, start with an example. No time like the present. Okay, so for example 1, let's say, oh, that's bad, h x equals cos x squared. So, h, we can write that, or write the formula as f with respect to gx and g with respect to x, being the function within a function, x squared within cos of that. Yep. Okay, so gx we will label as x squared, and f of gx we will label as cos gx. Oh, I really got to get more room. Okay, so derivative of h with respect to x is the derivative of f with respect to gx multiplied by the derivative of gx. So, find the derivative of gx. It's just 2x, and the derivative of f with respect to gx is just, I'll write down here, negative sign gx, because the derivative of cosine is negative sign. Okay, so if we sub those in, I'll write it out again, we'll sub it in. So, negative sign gx multiplied by 2x. If we rewrite this, we get negative 2x sine x squared, because we've brought the 2x and multiplied it to the invisible 1 on the negative, and we input the gx from up here. Okay, so that's the first derivative of this. And now for another example. Let's say hx equals 10 to x plus 1. We'll write out hx in this way, because this is the function within this function, if that makes sense. So, gx, hope it does, for your sake, is 2x plus 1, and f of gx, because now we've replaced gx with this, I'll replace this with gx, so the f of gx is now 10 gx. So, same as before, the derivative of h is derivative of f with respect to gx multiplied by the derivative of gx. So, find the derivative of gx, which is just 2, and the derivative of f with respect to gx is just, well, tan, the derivative of tan is sec squared, because, well, I could probably do a video later about proof, but that's just how it is. Tan, when you derive tan, you get sec squared, which is secant squared, I guess, if you want to be formal. But for now, subbing it in. So we have sec squared gx multiplied by 2. Rearrange that and make it look nice and pretty. You get 2 sec squared, and we input gx, so we'll put 2x plus 1 back in, and that is the first derivative of that up here. So, on to our third and final example. We'll have hx equals sine power of 3 2x. Now, that equals sine 2x to the power of 3, because that's just a neat way of writing it. I just thought I'd show you, just in case you come across it and you have no idea. Now you do. It's just, you basically, whatever, if that's a 2, you're square rooting everything there. If it's a 3, you're cubing, rooting everything in there. And yeah, you understand now. So, hx. Now, because there's the outside function, which is the power of 3, then the inside function, which is sine 2x, and then the inner function, which is 2x. So, we'll have f, and then g, and then I'm going to add a third one called j. I would add h, but we already called it h, so yeah. X, and then, so, we need to label j. We need to label g with respect to jx. We need to label f with respect to g with respect to jx. Sort of mumble jumble. So, if we separate the page, jx is the most inner function, which would be 2x in this case. So, jx equals 2x. The second most inner function, which is g, j, x, is sine, and we'll write jx, only because we already labeled jx. So, now, we have to label f with respect to g, j, x, which is g, j, x to the power of 3, because we basically replace sine 2x with g, j, x plus the brackets. So, now, derivative is f dash g, j, x multiplied by derivative of g with respect to jx multiplied that by derivative of jx. Hope you can see that. very tight on this page. So we'll sub that all in and get, oh wait, no, we have to find them first. Whoops, don't forget to do that. Derivative of jx is just 2. Derivative of g with respect to jx is sine, it's cos jx, because the derivative of sine is cos, and the derivative of f with respect to g with respect to jx is 3 g j x to the power of 2, because you treat it like the power rule. You bring the 3 down and you take 1 off the power. Okay, I'm going to rewrite this on another page because I think we're going to run out of room. So let's say h, derivative of hx, we already wrote that, so derivative of f gjx, which you've called 3 mumbo jumbo, so 3 g j x power of 2 multiplied by derivative of g with respect to jx. Now we've said that is cosine of jx, written as cos jx, multiplied again by the derivative of jx, which is just 2. So now we can simplify it. Bring the 2 at the front, multiplied by the 3, and we get 6. We'll input gjx back in, which is jx is 2 and gjx is sine jx, so that'll be sine 2x. Then we put a power of 2 up here, and then multiply it by cos, input the jx, which is 2x, and then that there is the first derivative of this up here. Hope this helps. Thank you for watching.